all developers, AI Camp have grown to over 50,000 tech engineers in group, have hosted over 300 local tech meetup, workshops, bootcamp, large tech conferences, and live stream most of the tech talk globally. We have local study groups in most major cities in the US, a few cities in Europe, India, China, Australia. You can take a look at the website to see our upcoming tech talks, workshops, and the crash course that we offer. Here's at the webinar we are of upcoming week. Next Monday at 10 o'clock, we have Building Gan with Petra. Next Friday, we have Build Your First AI Chatbox workshop. And we still have the bootcamp training in Los Angeles and Seattle in the next January. Most importantly, we will have our AI Next Seattle conference from January 23rd to 26th. It will be 4 days, 50 plus tech lead speakers, 60 plus tech talks, 6 workshop code lab, presented by engineering students from Microsoft and Amazon, Uber, Airbnb, Kubernetes, Google, Facebook, list. Buy the ticket before the Friday to get a 50% discount. We are excited to have Garland, Development Operation Engineer. Today we will follow through the example to how to develop training and serve as a trained model or running in Kubernetes. We will go to detail on the workflow is doing under the hood to understand more of the magic that is happening. At the end of the demo, we will learn how to deploy the WorkCamp Kubeflow, set up training, and serve as the request via the web pages. Before we get started, just want to tell a little background about Garland. Garland is a develop operations software engineer that helps small to medium-sized startup run large-scale retail application. Garland works as an entire development team architecting, design, building, optimizing, and the operation in factory in the cloud, AWS, Google Cloud, and the other. In addition to help customers build, Garland write for Barry below to help the community use their Kubernetes base in factory. Without further ado, let's welcome Garland.
Thank you. Yeah, let me start sharing my screen. Thanks for the intro. Can you guys hear me?
Yes, we can hear you.
Cool. Yeah, so if you pass me the, give me presenter, I can start sharing my screen. I think you have to unshare your screen first. Yeah, so just give you a little bit more background on this talk while she's doing that. This is, we're going to follow a tutorial, and I'm more of a DevOps operation engineer, so definitely by no means a machine learning expert. However, I have operated a lot of these network as a contractor consultant for various companies. So yeah, I know a good deal about it. What I'm really mainly going to show you here is how to run through this tutorial and what is actually happening under the hood on Kubernetes. Things that you'll run into, things that will help you troubleshoot why this tutorial is not working for you exactly how I kind of laid out. Yep. So.
Garland, I think you can just share your screen. Yeah.
Okay. Cool. Yep. Now I can share my screen. So yeah, so let's get started. This tutorial is fairly long. There's some parts that takes a little while. So you can actually go see the tutorial over here. So there's nothing really new created here, but a lot of augmentation on problems and things that you'll run into. Sometimes the hardest part is really the setup, right? We're talking about Well, let me back up a little bit. What are we going to set up here? So what we're setting up here is a GitHub issue summarization model that will spit out a title for you based upon the text. What it will do is we're going to use Kubeflow, TensorFlow, Seldom Core, and we're going to train a model and then serve it out through their UI and a custom UI that was built for this tutorial. So the setup, what you need for this setup is a Google, the easiest thing to do is get a Google Kubernetes engine. You can go do that in the shell. You can go do that in the GUI. You can, if you signed up for Google, Google has, will give you a bunch of, a little bit of credit to help you get started. And you could just kind of work your way over here and click Create Cluster. And it will create the cluster for you. You really don't need to change much of these things. One thing you might want to change is the CPU size, right? Like you want to have enough memory and CPU for mainly training the model, the job that takes. And I'll show you why in a second. There are a lot of options here, but you can mainly skip over most of those and just go with a standard cluster and hit create. I'm not going to hit create because that takes a while. I already have a cluster created here sitting for you guys. And so some of the other things is, get your GitHub token. And one of the other things is set up your project ID. They tell you to set up this project ID, get your project ID, but where is this project ID? So if you go to your GCP project, you can hit Manage Kube or hit this drop down, and it will drop down all the projects, and it'll open up this window here, and you can see the projects. And so this is the project ID. So you just kind of copy that and set it into your shell. This is to configure Docker, give your local Docker the authentication it needs. This here is to give, to set up a service account on Google so that it has access over to your GCP buckets, because the training models will output to these buckets. So the containers that are running in Kubernetes will need access to the buckets. So this stuff is here to set up that access. And of course, this is to create the bucket with the Google utility GS utils. And they're also showing you how to create a cluster via the command line, right? Like what I told you earlier to do. And this creates the cluster, and then once you have the cluster, you can run a command such as this to get the info. So for example, I have a cluster up running here. It'll tell you the cluster's IP and things like that. Let's see, any other gotchas? So another way to get your project ID number is you can use the GCloud commands. So if you go GCloud project list, you can list out all of your projects, and then the project ID is actually this column and not the project number. So the project ID, the title gives you the project ID. And it goes to the service account that I was talking about. Yeah, so if you weren't like a command line person and you kind of like looking at the GUI, I sometimes do, because command lines sometimes are a little bit abstract. You don't get to see what's going on around it. Usually command line only gives you the information that you basically just asked for and nothing around it. You can also, go over to your Google Cloud console, and if you click on this ellipse thing over here, it'll drop down, and you'll see an item that says storage, and you can browse your storage, and you can see the buckets that were created here, right? And you can kind of view the files and things like that. As we move along in this kind of tutorial, it tells you to do this K-Sonnet stuff. And so the question is, okay, what is K-Sonnet? And what are all these files that, it told me to go and get, and what are these commands that I'm running? So K-Sonnet is at the heart of it is really a templating language. It helps you templatize configurations to be applied onto a system like Kubernetes. And the reason why you want to do this is because you want to make these configuration portable, right? You don't want to hard code like image names, CPU memory and things like that right into your configuration, because then it's not portable, right? Like, it worked for you, but let's say when you deliver it to, say, your QA team, or someone wants to actually run it in production, some of those values are going to have to change. So certainly the templating language and, this wrapper around your config makes it a little harder, but then also makes it portable, right? Where different groups and teams can kind of utilize what you have built and run it themselves. So, following the example, KS init kind of creates the scaffolding around Kubesonnet, gives you the file structure and things like that. And then in this example, it has you copy some of the files over to components. So it's like, copying these the UI component over into your local folder components. And we can look at some of these files, right? So we can let's look at some of these files, UI, JSON, right? So these are really just setting parameters for, setting parameters and imports and things like that for your configuration, right? So we can look at something like issue, and so we're saying, hey, the namespace thing is a Kubernetes thing, setting up parameters for the image, the name, the namespace. So these are usually standard parameters where, to make it portable, really, so that, I run it, I might want to name it something. I might have a different container image name, right? Because I'm testing and maybe I'm developing this stuff. So I would have a lot of development containers. And then finally, when I'm ready to be like, okay, cool, this container is good, I would push that and maybe tag it as, RC candidate or release number 1 or whatever. And then whoever's going to consume this stuff, I either publish like a GitHub a post about it, a release, or just tell them to, hey, use this image, it's stable. Then, they can take all of this stuff and parameterize it to their own needs, right? And then, so this KS package stuff is really, we're also using, like I was saying, that we're using Seldom to do the serving and training. And then there's the Kubeflow core. So this is just pulling in dependencies. So basically, Kubeflow is a huge multi-project kind of workflow that kind of grabs everything together, right? So instead of me creating the entire workflow from scratch, I'm using this framework, and this framework has these dependencies that you kind of grab in. Yeah, so you then, let's see, we can go back to the slides. So then you can create an environment, right? Like, so you have to tie environment to K-Sonnet. So K-Sonnet, you download the tool, it doesn't know that, hey, this is the cluster, this is the GKE cluster that I want to use. So basically, you can add an environment, and this is how you do it. Right? You add an environment, and which ties it to that cluster. So now, whenever you run any ksonnet command, it would go to that cluster. And then after that, you set parameters. You see these environment parameters. KS parameters set Kubeflow, TF ambassador service type load balancer. So remember what I was just showing you earlier was that these are the parameters, and then so that command is just setting the parameters. It's just setting the parameters. So we can look at something like if we grep something like the ambassador, grep this. So we can see, so this particular parameter is setting the params in this file for this ambassador type. So on default, right? On default, it's a cluster IP. So this is really a Kubernetes thing, right? Cluster IP means that it's only inside the cluster. You can't access it outside. But for this tutorial, it's going to be a problem, right? Because we want to see a UI and things like that. So what this means is if you set it to a type load balancer, Kubernetes will create you a load balancer and point it to this stuff for you so that you can reach it on the internet. Right. Yeah, so anytime you see some command that says like ks apply GKE, that means it is actually going to go and do something on the cluster. It's going to launch something on the cluster. It's going to change something on the cluster. It's manipulating resources on the Kubernetes cluster there. Yeah, so this is the parameters I was just talking about. But so yeah, so let's launch this, right? So set the param GKE. So let's apply this, right? So you'll see a bunch of stuff happening here. So it's applying all of these configs basically. Basically, it's taking all of the parameters that we've set before, right? Some of these parameters that we've set before, and then it's applying all the Kubernetes config to the GKE cluster here. So we go kubectl get pods. We can see a bunch of stuff that just launched, right? Like there's 12 seconds, it just launched. So another trick is -OY. That gives you a little bit more information on the IP address it's been given and the node that it is on. So so one problem here is that so some of them has launched, some of them are in pending state. So the question is, why are they in a pending state? So we have another command. You can describe a pod, and you describe a pod from the pod name. And it is basically saying there are nodes. So this is the latest, this is one of the latest ones. So it's basically saying there are no node available with 3 insufficient CPU. And then, so Kubernetes does have, GKE in particular, creates all this stuff for you. It has this thing called an autoscaler. And it basically looks for stuff that can't be provisioned and then scales out another node for you. So what this is saying is that the cluster autoscaler, say the pod triggered a scale up, right? There's some stuff that nobody understands. But the important part here is that you see this 1 to 2. It means that there was 1 node here, and then it's going to go and bring it up to 2 nodes. And this is the maximum number of nodes that are allowed. So right now, Kubernetes is bringing up some nodes. We can see that by this command called get nodes. right? And we see that 4 seconds ago and 27 seconds ago, a new node just came up because of this stuff right here, right? This node isn't ready yet, but however, this one that came up 27 seconds ago is ready. So we can do a git pause -o wide. And then now we see these pods are creating in a creating state. If we look at it with the describe pod again, we can see that this scale up thing happened, and then it started to do other things. Finally, it assigned the ambassador to this node right here. And then it started pulling images and starting images. And so you're like, okay, cool. It's finally starting. And things are starting, right? So let's move on because this is going to take a minute. So we go through training the model. So it goes say, hey, set some more KS commands to set images, right? Like your environment is GKE. For this thing, we want this to use this Docker image. So this is a Docker image. This is a Docker image, and you can go and pull this Docker image if you wanted to. If you go like Docker pull this, right? It's gonna go and pull this image. These are all public images since they are in a tutorial. I'm not gonna finish pulling this thing, but you can pull this image down. You can exec into it and look at it and and play around with it. All right, so we're gonna launch this training job, right? So it's already been launched before, so that's why you get this error message. But however, we go and look at it, we see this summarization this summarization job starting up. So we can describe job or describe pod and see what's going on. So it's pulling the image, great. It's pulling the image. And then then this training job kind of trains it, and it outputs this information to you. This is going to take a while, so I'm not going to run through this right here. I'm going to kind of skip over this area. But at the end of it, you should get this stuff in your bucket, right? You should see this stuff in your bucket. If you list your bucket, you can do this on the command line, or you can go into the web GUI and look at it. So the next thing is to serve up your model. So what we want to do is to provide a RESTful interface so that something can get this model, right? So what we're going to do is create the KSonnet configurations for it. So what this is saying is that this is the image that, once again, this is the Docker image that we want to use. We're setting that variable. And then this generates out the configuration for our Soldom serve framework, right? It sets the image, it sets the name, and then the replica is setting how many pods, containers I want Kubernetes to run for me, right? So I already had that set before, so I'm gonna just apply it right here, right? Kind of doing this stuff quick because it takes a little while to download the stuff. So I applied it. So let's go kubectl get pods -o wide. I want to see all the stuffs. So we can see this issue summarization being created 8 seconds ago. So let's let that create and jump back over the slide and let me show you something. So that was the group scaling up, right? So on the training side, you might find that if you didn't pick a large enough node, that when you go do a git pods-oy, you might see some status like evicted or OOM, right? That's usually if you didn't pick like a node with enough memory. So how do you figure what happened there? So you do a describe pod, right? You do describe pod. So describe pod will be a very good friend of yours because it tells you information about what Kubernetes is kind of doing on the underlying system and where the magic is happening. So when you describe a pod, you'll see that you see some messages here. It created the container, it started the container, so that's cool. So that means that there's nothing wrong with your configurations or anything like that. Kubernetes was able to start it. However, the node was low on resources memory, and then it killed the container because it was low on memory. So what can you do about that? The easiest way is to go into the workflow, the console, and go into your cluster that you created. Edit that cluster, right? Like you click edit. You can add in another node pool and select the machine type that has a bigger CPU and more memory, and then launch this on. And then click OK and launch it. And then when you launch it, you wait for 5 minutes or so. Then you'll see that the container is created on this new pool. So, we named it like new pool, and then you'll see it, name on new pool. So this usually will take like 5-10 minutes before, the new node comes up with, the increased memory and CPU. So then it creates and it will proceed to run, right? So let's go back to what we're doing here, and let's see if this stuff has launched. So great, that stuff has launched. So we can kind of continue on to adding the UI. So the UI is just a component in all of this stuff. So again, we're doing the same thing. We're setting the UI parameters and things like that. So again, you'll see the service load balancer because we do want to expose it out to the internet. By default, this example, that they've given you here in this GitHub, has defaults where it's more for local type development, right? It's not exposing to the internet and things like that. But to make it easier for us, we're going to expose it to the internet. So this tutorial goes on, to say that you can create your own UI image if you wanted to. And, for sake of time, we're going to kind of skip this step because it takes a little while to build and push. But we're just going to launch the UI that they have given us. So it's launched. So we can see, once again, we do the Kubernetes kubectl get pods-oy. We see that the UI is being created here. And it's in pending state. We can describe it. So another trigger scale up happened to be able to run these nodes. So so the good thing about Kubernetes is that the cluster will scale up and down as you need it. So I don't have to kind of go mess around with it. And then once this demo is over, when I delete everything, the autoscaler, the cluster autoscaler will scale everything down for me, right? So I could wait for that. And then the other thing is you could get service, right? And this is the load balancer that we asked Kubernetes to create us. And here goes the public IP of that load balancer. And so what I'm actually waiting for is this container to come up so that we can go to a UI, just like the example said we would be able to. And once that is up and running, we can look at it. But from working with this demo for a while, I already know that there might be a problem. So let's check that problem out. So I'm looking at this summarization issue. This is the REST API that the UI queries for information. And the problem is that you see this 0 of 2. That means that this is not ready. So none of these are actually ready except for this one maybe. So this one is not ready and is not behind the load balancer. So one thing you can look at is what is actually behind this load balancer. So we copy this. We go kubectl describe service, because this is a type service, right? So we describe that service. And we look at the endpoints. So there's actually no endpoints behind it, which means that if I go to this load balancer, it's not going to be able to route me to anything. So what I would do, so all of these are really in a crash loop backup. There's a problem with these issue summarization. The first thing usually in Kubernetes, I can look at the logs or I can just delete the pod. I can delete the pod and let Kubernetes recreate it by itself. And hopefully the Kubernetes magic will help me out here, right? And fix all my issues by just simply restarting it. And maybe it didn't have a dependency that it needed or whatever, right? So these containers are recreating. Looks like the UI is actually running. We can look at the logs on these guys, right? So you can go get logs -f for follow. Oops, not get logs, just logs. And I guess it's starting, right? It's starting, and it's debugger's active and it's running on port 80 right there. So we do have to wait for the REST API to come up, but we can actually try to go. We can actually try to go to this load balancer, and let's see this load balancer. Okay, so now there's actually an endpoint behind it. This 50, the UI finally started, and this 55.3 address is this 55.3 address here. So I think I can go to this load balancer now and be able to get something. Perhaps. We can look at the logs. If not, I think something just showed up. And yes, I do see my GET request here. So if I repopulate this thing, reload this thing, I do see another GET. So cool. It's hitting this web UI here. And then we're still waiting for these to create. We won't be able to query anything just yet because these backends where the UI queries is not there. We can try. And it did something. Okay, cool. So it's working now. So it got the random issues that it wanted to look at. So that model is being served up by the RESTful API that we've launched back there. So I guess the thing is, how do we visualize what is actually happening here and what is the traffic request flow that's happening? From the internet, I'm going over to a Google load balancer here. That is that load balancer that we've requested. And then it's going into the issue summarization UI to get the HTML that we were seeing over there, the front end where the buttons are, and then it's going to the issue summarization container back there to ask for an answer to the post questions that we've asked for the GitHub issue. So that is a quick run through of the demo, and hopefully giving you some insights on the back end quickly on what it's actually doing on Kubernetes and what the magic is back there. Are there any questions now, I guess?